A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
Have you ever had that feeling where you are using an AI tool that you rely on every single day, and suddenly it just feels off? Like it lost its edge, or it is suddenly giving you shorter, lazier answers to questions it used to handle with ease? It is a common complaint in developer circles and among power users, but for a long time, the companies behind these models basically told us we were imagining things. They called it vibes or user bias. They told us the benchmarks were higher than ever, so clearly the problem was with our prompting or our expectations. But as we are seeing more frequently here in early 2026, that feeling is often backed by some pretty harsh technical realities. Welcome back to My Weird Prompts. I am Corn Poppleberry, and today we are digging into the phenomenon of the digital recall. We are moving past the myth of the always improving machine and looking at why the most advanced systems on the planet are sometimes forced to take a massive step backward.
Herman Poppleberry here, and Corn, you are hitting on something that really gets under my skin. We have been sold this narrative for years that AI progress is this straight line pointing up and to the right. The marketing departments at these labs want you to believe that every new version is strictly better than the last in every single metric. But if you look at the actual history of these releases, especially over the last 18 months, it is a lot messier. It is more like a series of 2 steps forward and one very public, very expensive step back. Our housemate Daniel actually sent over some thoughts on this earlier today, asking about why we are seeing these high-profile regressions and what happens when a model is so degraded that it essentially has to be recalled or quietly decommissioned. He noticed that the coding assistant he uses for his Python work has been hallucinating library imports that haven't existed since 2022, and he wanted to know if he was going crazy or if the model was actually unlearning things.
It is a great question because it challenges the fundamental myth of the always improving machine. When a car company has a faulty brake line, they issue a formal recall. Everyone knows about it. It is on the news. But when a multi-billion-dollar language model starts hallucinating facts it previously knew, or loses 15% of its coding accuracy overnight, the recall is often silent. It is a patch, a rollback, or a series of desperate system prompt adjustments behind the scenes that the user never sees. Today, we want to peel back the curtain on why this happens. We are talking about the technical debt, the alignment tax, and the specific failures that have defined the last few years of development. We are moving out of that initial era of wild, unbridled scaling, where you just throw more compute at the problem and hope for the best. Now, we are in the era of efficiency and safety, and that is where the friction really starts. Before we dive into the mechanics of why these models fail, let's define what we mean by an AI recall. In a traditional sense, a recall is about safety or functionality. In AI, a recall usually happens when the post-training process, the stuff they do to make the model helpful and harmless, actually breaks the underlying reasoning capabilities.
It is the alignment tax. We have talked about this briefly in passing before, but it is worth a deep dive today. When you take a raw base model that has been trained on a massive chunk of the internet, it is incredibly capable, but also totally unpredictable. It might give you instructions on how to build a bomb just as easily as it gives you a recipe for chocolate chip cookies. To make it a product, you use reinforcement learning from human feedback, or RLHF. You are essentially pruning the probability tree. You are telling the model, don't say that, say this instead. Be more polite, be more concise, don't mention certain controversial topics. But the problem is that when you prune those branches, you aren't just cutting off the bad stuff. You are often cutting off the pathways the model uses for complex reasoning or creative problem solving. It is a fundamental trade-off that the industry is only now starting to admit is a zero-sum game in many cases.
It is like trying to perform surgery with a sledgehammer. You want to remove a specific tumor of bias or toxicity, but you end up damaging the motor skills of the entire system. And this leads to what we call catastrophic forgetting. Herman, explain how that works in a fine-tuning context, because I think people assume models just add new knowledge on top of the old, like a person reading a new book.
That is a huge misconception. Think of a model's weights as a giant interconnected web of billions of parameters. When you fine-tune a model to be safer or to follow a specific persona, you are physically changing those weights. You are shifting the mathematical relationships between words and concepts. If you push too hard in one direction, say, making the model extremely averse to generating anything that could be remotely controversial, you are overriding the weights that were previously dedicated to, say, historical analysis or nuanced debate. The model doesn't just learn to be polite, it literally forgets how to be deep. This is why we saw that huge outcry about GPT-4 laziness back in late 2023 and throughout 2024. Users were reporting that the model would give them code snippets with comments like, "Insert logic here," instead of actually writing the logic. It wasn't that the model was tired or bored, it was that the alignment process had incentivized brevity and safety to such a degree that the model's path of least resistance was to just not do the work.
I remember that vividly. It was infuriating for anyone trying to use it for actual production work. You would ask for a script, and it would give you a template. It was like the model was trying to do the bare minimum to satisfy the prompt without using too many tokens or risking a hallucination. And the technical reason for that was likely a combination of overalignment and aggressive quantization to save on inference costs. Let's talk about quantization for a second, because that is a major driver of these silent downgrades. If alignment is the surgery, quantization is the starvation diet.
Oh, quantization is the silent killer of performance. For the listeners who aren't knee-deep in the infrastructure side, quantization is basically reducing the precision of the numbers the model uses. Imagine trying to do high-level calculus, but you are only allowed to use whole numbers instead of decimals. You can still get close to the answer, but you lose the nuance. Companies do this because running a full precision model with hundreds of billions of parameters is astronomically expensive. If they can squeeze that model down from 16-bit precision to 4-bit or even 2-bit precision, they save a fortune on hardware and electricity. They can serve 10 times as many users on the same number of GPS.
But you pay for it in accuracy, and that brings us to the Model X failure in January of 2026. This was a massive story in the dev community just a couple of months ago. This was supposed to be a flagship update for a major proprietary model. They promised better reasoning, longer context, and faster speeds, and on day one, it seemed fine. The marketing was slick, and the initial benchmarks they released looked incredible. But within 48 hours, the real-world benchmarks started coming in from independent researchers and developers on GitHub. Coding accuracy on complex Python tasks had dropped by 15% compared to the previous version. 15%. In a production environment, that is the difference between a tool that works and a tool that breaks your entire code base.
It was a total dud. And what was interesting about the Model X situation was the cause. It wasn't just RLHF gone wrong, it was a failed implementation of a new quantization technique that was supposed to be lossless. It turned out that for certain types of mathematical and logical reasoning, the loss of precision caused the model to fall into these repetitive loops. It would get stuck in a logic gate and couldn't find its way out, so it would just hallucinate a plausible sounding but incorrect conclusion. They eventually had to roll it back and re-release the previous version under a new name while they went back to the drawing board. That is a digital recall in action. They had to pull the product from the shelf because it was fundamentally broken for its primary use case.
And they didn't call it a recall. They called it a performance optimization based on user feedback. It is that corporate speak that drives me crazy. They knew they broke the engine, but they tried to frame it as a minor tuning issue. It reminds me of what we discussed back in episode 808, the AI deprecation trap. We are seeing this cycle where a model is released. It is great. Then it gets aligned and quantized into oblivion until it is barely functional, and then they release a new version to start the cycle over again. It is almost like they are managing the decline of the model to force people toward the next pain tier.
It is a cycle of planned obsolescence, but driven by technical limitations rather than marketing. But let's look at some of the more obscure failures, because I think they tell a more interesting story about where the industry is struggling. Do you remember the Galactica launch by Meta a few years back? That was a classic example of a model being recalled almost instantly because it couldn't handle the reality of its own output. It was a precursor to the problems we are seeing today.
Oh, Galactica was a fascinating disaster. It was marketed as a tool for scientists, something that could summarize papers, write literature reviews, and help with research. But because it was trained so heavily on scientific text without enough grounding in factual verification, it started generating fake scientific papers that looked incredibly convincing. It would cite real authors but invent the results. It would create plausible-sounding chemical formulas that were actually explosive or toxic. It lasted, 3 days before they pulled the plug.
Less than that, I think. It was a victim of its own success in mimicking the style of science without understanding the substance. And that is a recurring theme in these failures. We see it in specialized models for the legal or medical fields too. There was a medical diagnostic model used by a startup in 2025 that was supposed to help radiologists. It performed at a 99% accuracy rate in the lab. But when it hit the real world, it turned out the model had learned to identify the type of X-ray machine being used rather than the actual pathology. Because one hospital had older machines and a higher rate of a certain condition, the model just associated the machine's digital signature with the disease. When that came to light, it was an immediate decommissioning. That is a technical failure of generalization.
That is the hidden technical debt. You build a model on biased data, or data that contains spurious correlations, and you don't realize it until it is in the hands of users, and then you have to pull it. This brings up an interesting point about the conservative worldview we often talk about. This idea of being grounded in reality and tradition, rather than chasing the latest shiny object. In the AI world, there is this progressive push to automate everything, to replace human judgment with these massive black boxes. But the failures of these models show that we are often moving faster than our understanding of the technology allows. We are building skyscrapers on sand.
I agree. There is a lack of humility in the way these models are deployed. We treat them like infallible oracles when they are actually very fragile statistical engines. When you look at the way some of these companies are pushing for global alignment or safety filters that reflect a very specific, often left-leaning ideological bias, you see how that impacts the model's utility. If you train a model to be so afraid of offending anyone that it can no longer accurately describe historical events or discuss complex policy issues, you have effectively broken the tool for anyone who needs it for serious work. You have recalled its intelligence in favor of its ideology.
It becomes a sanitized version of reality that isn't actually useful for solving real-world problems, and that leads to model drift. Even if you don't change the weights, the way the model is prompted or the way the safety layers interact with the output changes over time. We have seen instances where a model becomes significantly worse at objective analysis because the safety layer is catching too many false positives. It starts flagging benign technical discussions as harmful because they contain keywords that are also used in controversial contexts. It is like a security guard who starts tackling everyone who walks through the door just to be safe.
It is the problem of the invisible guardrails. Users don't know why the performance is dropping. They just see the results getting worse. And this leads to a second-order effect that I think is going to be the biggest challenge of the next few years: model collapse due to synthetic data loops. This is a huge technical hurdle that we are just starting to hit the wall on in 2026. As more of the internet is populated by AI-generated content, new models are being trained on the output of older models. It is like a digital version of inbreeding.
That is a terrifying thought, but it makes perfect sense. If you are training a model on data that has already been sanitized, aligned, and quantized by a previous generation of AI, you are losing the raw, messy diversity of human thought. The model's worldview shrinks, the vocabulary narrows, the reasoning patterns become more repetitive. We are already seeing signs of this in some of the smaller models that rely heavily on synthetic data for their training sets. They are great at following instructions, but they have zero creativity. They hit a wall very quickly when you ask them to think outside of the patterns they were trained on. They become caricatures of intelligence.
It is the Habsburg royalty of AI models. You end up with these systems that are technically functional but intellectually stunted. And this is why we are seeing a shift away from the giant, general-purpose models toward what we call small language models, or SLMs. People are realizing that a smaller model, trained on high-quality, human-curated data for a specific task, is much more stable than a trillion-parameter behemoth that is constantly being patched and recalled. We are seeing a move toward models like the Phi series or the smaller Llama variants because they are predictable. You can audit them. You can understand why they are making the decisions they make.
I think that is a very healthy development. It is a return to a more modular, predictable approach to software engineering. You wouldn't use a single piece of software to manage your taxes, fly a plane, and write poetry. Why do we expect one AI model to do all of those things perfectly? The failures of the last few years have shown us that the general-purpose dream might be a bit of a mirage, or at least a lot harder to achieve than we thought back in 2023. We are seeing the limits of scaling laws. You can't just keep adding parameters and expect the model to become a god. Eventually, the complexity becomes unmanageable.
It is a reality check. We are currently in that trough of disillusionment on the Gartner hype cycle, which we talked about in episode 791. The initial excitement has worn off, and now we are dealing with the hard engineering problems. One of those problems is how to maintain a model in production without it regressing. How do you issue an update that improves feature A without accidentally breaking feature B? In traditional software, we have unit tests and regression testing. In AI, it is much harder because the output is probabilistic. You can't just check if the output equals 5. You have to check if the output is within a certain range of correctness across 10,000 different prompts.
Right. You can run a benchmark of 1,000 questions, and the model might pass 990 of them. But that doesn't mean it won't fail spectacularly on the 991st question in a way that is totally unpredictable. This is why developers need to start treating AI models like volatile dependencies rather than static libraries. You can't just point your API to the latest version and assume everything will be fine. You have to maintain your own local evaluation pipeline. You have to be your own quality control department.
That is the number one takeaway for anyone building with these tools. You need your own set of ground truth data that is specific to your use case. If you are building a coding assistant, you need a suite of 1,000 coding problems that you know the answer to. Every time the model provider pushes an update, you run that suite. If the accuracy drops by even a few percent, you don't upgrade. You stay on the old version. You have to be the one who issues the recall for your own application, because the provider probably won't tell you they broke it until it is too late.
It is about taking back control. Don't rely on the hype or the release notes. Rely on your own data. And this brings us to the idea of model versioning. We are seeing more companies offer access to specific, dated versions of their models, like the June 2024 version or the October 2025 version. This is a direct response to the community's demand for stability. People would rather use a slightly older, slightly dumber model that they understand than a newer, potentially smarter model that might hallucinate in the middle of a critical task. Stability is a feature, and for a long time the industry ignored that.
It is the difference between an experimental prototype and a reliable tool. If you are a professional, you want the tool. You want the hammer that is the same weight and balance every time you pick it up. You don't want a hammer that occasionally turns into a screwdriver without telling you. This shift toward predictability is going to define the winners and losers in the AI space over the next couple of years. The companies that can guarantee consistency are the ones that will win the enterprise market. The ones that keep chasing the next benchmark high while breaking their existing features will be relegated to the hobbyist market.
I totally agree, and I think we are going to see a lot more transparency around these regressions. As the industry matures, we are already seeing independent watchdogs and open source communities doing their own audits. There is a real sense of accountability starting to form. People are calling out these silent downgrades on social media and in developer forums, and it is forcing the big players to be more honest about the trade-offs they are making. They can't just hide behind the black box anymore.
It is a great time for the open source community, actually. Because models like Llama 2 and its successors are available to be run locally, they don't suffer from the same silent updates as the proprietary APIs. You can download a model, verify its performance, and know that it will never change unless you decide to change it. That stability is incredibly valuable. It is why we are seeing so much innovation in the open source space right now. People are building on top of a foundation that they actually trust. They are building their own safety layers and their own fine tunes that are optimized for their specific needs.
It is that decentralized, self-reliant spirit that we always champion. Don't trust the big tech gatekeepers to have your best interests at heart. They are optimizing for their own bottom line, which means cutting costs on inference and compute, often at the expense of your user experience. If you can run it yourself, do it. If you can't, at least make sure you are monitoring it like a hawk. Use tools that allow you to compare outputs across different versions in real time.
Speaking of monitoring, let's talk about the future of self-healing models. This is a concept that is starting to gain some traction as a way to prevent these recalls. The idea is that you have a second, smaller model that acts as a supervisor. Its only job is to watch the output of the main model and detect when it is starting to drift or hallucinate. If it detects a failure, it can automatically trigger a retry with a different set of parameters, or even fall back to a more stable, older version of the model. It is a system of checks and balances within the architecture itself.
That is a very elegant solution to the problem of model volatility. It is essentially building a safety net into the architecture itself. It is not about making the model perfect, it is about making the system resilient to the model's imperfections. It is a very engineering-centric way of looking at the problem. Instead of trying to train the perfect oracle, you build a robust system around a flawed but powerful engine. It is how we have always built complex systems, from bridges to spaceships.
It is how we build everything else in the world. We don't build planes that can't crash, we build planes with redundant systems and black boxes so that if something does go wrong, we can understand why and prevent it from happening again. We need that same level of rigor in AI. The era of just playing with these models like toys is over. Now we are building infrastructure, and infrastructure needs to be reliable. We need to move from the move fast and break things phase to the move carefully and build things that last phase.
I think that is a perfect place to start wrapping things up. We have covered a lot of ground today, from the alignment tax and catastrophic for getting to the Model X failure and the rise of small, task-specific models. The key takeaway is that progress isn't a straight line. It is a messy process of trial and error, and as users and developers, we have to be vigilant. We have to be the ones who demand quality and consistency from the companies that are building these tools.
Definitely. Don't be fooled by the marketing. Always verify, always test, and always have a backup plan. The digital recall is a real phenomenon, and it is something we are going to be dealing with for a long time as these models continue to evolve. But if we stay grounded and focus on the technical realities rather than the hype, we can navigate this landscape successfully. We can use these tools to augment our intelligence without becoming dependent on systems that we don't understand and can't control.
Well said, Herman. This has been a fascinating deep dive, and before we go, I want to give a quick shout out to our friend and housemate Daniel for sending over the prompt that sparked this whole discussion. It is always great to have a starting point that challenges our assumptions and forces us to look at the data. Daniel, I hope this helped explain why your Python bot has been acting like it is from 2022.
Yeah, thanks, Daniel. And to our listeners, if you have been enjoying the show, we would really appreciate it if you could leave us a review on your podcast app or over on Spotify. It genuinely helps other people find the show and helps us keep this collaboration going. We have been doing this for over 1,000 episodes now, and we love seeing the community grow. Your feedback is what keeps us digging into these weird corners of the tech world.
It makes a huge difference, and if you want to make sure you never miss an episode, you can find all the links to subscribe at myweirdprompts.com. We have the RSS feed there for the purists, and you can also find us on Spotify. Also, if you are a Telegram user, search for My Weird Prompts and join our channel there. We post every time a new episode drops, so it is the best way to stay in the loop. We also share some of the research and papers we discuss on the show over there.
We are also looking into some more specialized deep dives for our longtime listeners, maybe some technical workshops on how to set up your own local evals, so stay tuned for that. There is always more to explore in this weird world of AI and technology. We are just scratching the surface of what it means to live in a world where our tools are constantly changing under our feet.
There certainly is. We will be back soon with another prompt and another deep dive. Until then, stay curious, keep testing those models, and don't take anything at face value. If it feels like the model is getting dumber, it probably is. This has been My Weird Prompts.
Herman Poppleberry, signing off. Thanks for listening, everyone. We will catch you in the next one.
Peace.
Take care.
So, Herman, I've been thinking about that medical model you mentioned. The one that was identifying the X-ray machine instead of the disease. It is such a perfect example of what is wrong with the black box approach. If we don't understand the why behind the output, we are just guessing. It is like a doctor who gives you a diagnosis based on what shirt you are wearing.
It is the shortcut problem. Neural networks are incredibly good at finding the path of least resistance to a high score on a benchmark. If the machine signature is a reliable predictor of the outcome in the training set, the model will use it every time. It doesn't know it is supposed to be looking at the lungs, it just knows it wants to be right according to the loss function. That is why human oversight is so critical. We have to be the ones to say, wait, that doesn't make sense. We have to be the ones to provide the context that the model lacks.
Right. And that is where the conservative emphasis on human agency and responsibility comes in. We can't outsource our judgment to these machines. They are tools, not replacements for expertise. When we forget that, that is when the real failures happen. We become lazy, and then the models become lazy, and the whole system starts to degrade. It is a feedback loop of incompetence.
The tool is only as good as the person using it. And if the tool is regressing, the person using it needs to be smart enough to notice. It is a partnership, but the human has to be the senior partner. We have to be the ones who set the standards and hold the technology accountable. If we don't, we are just along for the ride, and that ride is getting increasingly bumpy.
Well, I think we have given people plenty to think about. I'm going to go check my own local evils for the script writing bot I have been working on. I have a feeling it might be getting a bit lazy lately, probably because I have been giving it too many easy prompts.
Ha! Just make sure it doesn't start leaving you comments like, insert joke here. That is when you know you have a problem. If it starts telling you to do your own work, then you know the alignment has gone too far.
I will keep an eye on it. All right, for real this time. Thanks for listening, everyone. We will see you next time.
Bye for now.
And remember, if you want to reach out to us with your own weird prompts, there is a contact form on our website at myweirdprompts.com. We love hearing from you guys, especially when you find a model doing something it definitely shouldn't be doing.
Yeah, keep those prompts coming. They keep us on our toes and give us plenty of material for the next 1,000 episodes.
They definitely do. All right, see ya.
See you go.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.